So let's continue with the problem solving session. This was one question which we skipped. Okay, now let's do that. At 298 Kelvin and 1 atm, the molar enthalpies of combustion of cyclopropane and propene are minus 2091 kilojoule per mole and minus 2058 kilojoule per mole respectively. The enthalpy change for the conversion of 1 mole of propene to 1 mole of cyclopropane is. So from the question itself you understand that this is a simple question which requires addition of two equations by the reversal of one. Okay, or maybe we may or may not have to reverse one equation, but simply we know the combustion for cyclopropane and the combustion for propene. We just have to find propane to propene conversion. So these questions are actually the simple ones. You just have to write down the equation in order to get an idea about that. So first let's write the first data given, that is combustion of cyclopropane. Cyclopropane we can denote it like this, and combustion means we will be using oxygen, and on combustion the products which are usually formed is carbon dioxide plus water. Now we need to balance this equation, so for that we actually need to write what is on the other side. Here it is C6. Okay, it's better to denote like this. This will be C6H 62, sorry, it is going to be C3H6. C3H6. But this is cyclopropane. I'll write it as Cp. Okay. So cyclopropane C3H6. The reason I'm writing it like this is because propene is also C3H6. But that is, the structure is different, right? One is like closed structure, the other is open structure. They are isomers which have same formula but different structures. So now if you want to balance, we have 3 carbons here, so you should have 3 carbons here also, and hydrogen we have 6 here and 2 here, so we'll put a 3. Now finally the oxygen, we have 3 2s are 6 plus 3, 9 oxygens here and 2 here. So here if you do 9 by 2, you will get 9 by 2 into 2, you will get it as 9. So on both the sides we have balanced the equation. Now what is the heat associated with the first one? Delta H is going to be, it is given as minus 2091 kilojoule per mole. Let's write it as delta H1. Now same reaction for cyclopropene also, propene also. So that is going to be again C3H6, but it is propene. Plus, we'll have same number of carbons and hydrogen, so we'll have the same equation. 9 by 2 O2 giving 3 CO2 plus 3 H2O. In this case, the delta H, let's denote it as delta H2, and the value is going to be minus 2058 kilojoule per mole. Minus 2058 kilojoule per mole. Okay. Next thing is, what is the required equation? That is first thing you have to note on. What is the required equation? What we need is enthalpy change for the conversion of propene to propane, cyclopropane. That means propene to cyclopropane. So if I want propene on the LHS, I have to take this equation as it is. And if I want cyclopropane on the RHS, I have to reverse this equation. Okay, so if I'm naming this as equation 1 and 2, I'll have to take equation 2 as it is and reverse equation 1. Let's try doing that. So this is going to be on reversing equation 1, I'll be getting C3H6 or for cyclopropane, we are reversing it, so writing the products first. There will be 3 CO2 plus 3 H2O giving C3H6, which is cyclopropane plus 9 by 2 O2. Now we can cancel out the common terms. What we are actually doing here is, let's write this as equation 3, and I'm going to add equation 3 plus equation 2. On adding, we have to consider these both equations. So 9 by 2 O2, 9 by 2 O2, 3 CO2, 3 CO2, 3 H2O, 3 H2O. Now what is left? you get C3H6 of propene to C3H6 of cyclopropane. Okay, now what is the delta H associated with this? Delta H, let's write it as 3. Here, since we are reversing this equation, if the forward reaction has a delta H of negative some value, then the reverse reaction should have a delta H of positive of the same value. So on reversing a reaction, your delta H will change, just the sign. There is no change in the value. Okay. So in that case, since we have considered both of this, now by Hess law of heat summation, Hess law of heat summation, if two reactions you add and you get a third equation, then their delta H values can be added to get the third delta H value. So if I add delta H2 plus delta H1, H2 plus delta H3, this is going to give me the delta H of the required equation. Okay, now let's add them. So delta H required is equal to, what is the value? Delta H2, that is minus 2058 plus delta H3 is 2091. So when I add of both of these, what will I get? I'll get around 33 plus 33. And what is the unit? Since both of these are in kilojoule per mole, the unit of this is going to be kilojoule per mole. This is the final answer. You just have to type in 33 there. Yes, so we got the correct answer, which is 33. Now let's go to the next question. This we have already done. This also we have done. Yeah, now the question on Latimer diagram. In this question there is a slight error. I'll just correct it. So please note this correction in the question. Okay, now the question is, in the following Latimer diagram, the species that undergoes disproportionation reaction is. Now this, even though you see all big Latimer diagram, we know that to see the species which may undergo disproportionation reaction, there is one simple rule. You might have already studied it. That is, if the reduction potential, okay, if the reduction potential on the right, means right side of the species in the Latimer diagram, is greater than the reduction potential on left side of the species in the same diagram. So if you look at this Latimer diagram, let's mark the species which is having higher reduction potential on right side. Now when you consider MnO4 minus, there is no way for it to further get oxidized. That means on the left there is no species, so we cannot consider that one. Let's consider MnO4 2 minus. So in that case, the right side is 0.27 and the left side is 0.56. So obviously left side is greater, so this species cannot be reduced. Now the next species, if you see, MnO3 4 minus. On the right side it is 0.93, on the left side it is 0.27. Obviously 0.93 is greater than 0.27, so this is a species that may undergo disproportionation. Now for confirmation, let's check if there is any other species also. For MnO2, right side is 0.15, left side is 0.93. Obviously left is greater. Mn2O3 minus and the plus value, so left is greater. MnOH twice, again minus 1.56 and minus 0.25. So in this case, one thing you have to notice is, even though it is negative sign, okay, or just because it is a negative sign, we will be considering a higher value to be lower than the lower value. You know, when you consider the number line, obviously minus 1.56 is going to come after minus 0.25, right, from 0. So because of this reason, we will be saying that this is a lower value than this. Okay, that means you are simply following the sign convention exactly as it is. So the only species which can undergo disproportionation among this given species in the Latimer diagram of manganese is MnO3 4 minus. So looking at the options, the correct answer is going to be MnO3 4 minus. Sorry, I made a mistake. It's not MnO3 4 minus, it's MnO4 3 minus. Please note that. This is MnO4 3 minus, because in the options also you see there is no MnO3 4 minus, it is MnO4 3 minus. So the correct answer from here is MnO4 3 minus. Okay. So the only rule is this one. Reduction potential on right should be greater than the reduction potential on left. Okay. The next question. The D spacing for first order X-ray, whose wavelength is 1.54 angstroms, diffraction event of metallic ion FCC at 2 theta equal to 20.2 degrees dash angstroms. So when you look at this question, the first thing that should come to your mind is Bragg's equation, right? So an equation that will connect the lambda and D spacing is Bragg's equation. So what is Bragg's equation? N lambda is equal to 2D sine theta. Now what are the data given? Is N given? Yes, it is given as first order, so N is 1. What about lambda? It is 1.54 angstroms. Just don't go and convert it initially itself. We have to see what is the case for D. If D is also in angstroms, then there is no need of unwanted conversions. Next to then D. How do we write D in terms of A? So you know that D is equal to A divided by root of h square plus k square plus L square. Oh, but the issue here is we do not know what is A or what is HKL. This thing as whole is unknown. And the question is actually to find D. So we need to find D. Next, what is given? Sine theta. For that theta, 2 theta is given as 20.2. 2 theta is given as 20.2. So theta is going to be 10.1 degree. Okay, now we have to find D spacing in angstroms. Therefore, there is no need of conversion of this angstrom. Okay, that is one important point you have to note. Since the when you see angstroms, we'll have a tendency to convert it into meter. But the answer is also asked in angstroms, so do not do any conversions. Now let's substitute the values. We need to get D. So D is going to be N lambda by 2 sine theta. That is going to be 1 into 1.54 divided by 2 into sine of 10.1. So we need to calculate these values. So the answer you'll be getting is around 4.39 and the unit is going to be angstroms. Okay, so this is the final answer. And they've asked to round off to 3 decimal places. So we need one more decimal place. And when I look at my answer, it's going to be, my answer was actually 4.3907 and I need to round it to 3 decimal places. So I will write it as 4.391. This is going to be my answer. Let's go to the next question. At constant temperature, 6.4 gram of a substance dissolved in 78 gram of benzene decreases the vapor pressure of benzene from 0.125 atm to 0.119 atm. The molar mass of the substance is dash gram per mole. So let's first write on the given data. Looking at the question, we see that there is a term mentioned as decrease in vapor pressure. So from this itself, it should strike you that this question is actually related to your lowering of vapor pressure, which is actually a colligative property. Okay, so there are certain phrases in the question that should strike you, and from that you should actually form or understand what equation has to be used. Now, since I got this decrease in vapor pressure, or this is that kind of question, the equation I'll probably have to use is delta P by P0 is equal to mole fraction of the solute. Okay, if I write it more accurately, it is going to be P0, let's name this as solvent. Solvent can be A minus PA divided by P0A will give me mole fraction of B. B can be my solute. So what is A here? A is benzene and some substance dissolved, that can be B. Okay. Now the question asked is to find the molar mass of the substance. So from this I can find only mole fraction. And from mole fraction what I need to find is the molar mass. Firstly, let's try to find the mole fraction. So what is the initial pressure of benzene? Initial pressure was 0.125. So 0.125 minus final pressure is 0.119 divided by initial pressure 0.125. This should give me mole fraction. So when I do this, I'll get a value of around 0.048. This is going to be my mole fraction of what? Of chi b. If I want to find the molar mass, I need to find the number of moles of substance. So if I want molar mass, I need to find number of moles of substance, and from mole fraction, if I want to find the number of moles of my solute, then I should know the number of moles of my solvent. Okay, so mole fraction of B is actually number of moles of B divided by number of moles of A plus number of moles of B. This value I know, this value also I know. Yeah, I need to find what is NB from this particular relation. Now what is the number of moles of benzene present? It is given as 78 gram of benzene, and also the molar mass of benzene is given. So number of moles of benzene, number of moles of A is going to be given mass by molar mass, which is which will be 1. This is equal to 1. So 1 mole of benzene is present. So now if I want to find NB, I can substitute in this equation. That will be taking the reciprocal. So Na, I'll take the reciprocal here. So I'll have 1 by chi b is equal to Na plus Nb whole divided by Nb. I can write it as by Nb by Nb. This term will go to 1. Now I have Na by Nb alone. So to get Nb, what can I do? What I can do is I will do 1 by chi b minus 1. Let's try that. 1 by chi b minus 1. What will I get? From in this case, I'm going to get only Na by Nb. Na by Nb. When I do 1 by chi b minus 1, I will get Na by Nb. Now from that, I want Nb. So I'll take Nb to RHS and this whole term to LHS, which means I have to do Na divided by 1 by chi b minus 1. I will get Nb. Okay. Don't worry about this part. It was a bit complicated, but when you do rearrangement on yourself, you'll be getting how to find Nb. Okay, so now I can put the values here. Na I already got as 1 divided by 1 divided by chi b 0.048 minus 1. So if I try to calculate this, my answer will be, for this I'll get 0.0504. Now the final step left is to calculate the molar mass of substance. So to get the molar mass of substance, what I have to do? Molar mass, the equation I know is number of moles is equal to given mass by molar mass. So to get molar mass, I can do molar mass is equal to given mass by number of moles. So given mass was 6.4 grams. So I can write 6.4 divided by number of moles. We have found it just now, 0.0504. 0.0504. Now let's calculate this one. The value I'll be getting is 126.9 grams per mole will be the unit because it is molar mass. So the answer I'm getting is 126.9. Okay. So here if you look at this, here if you instead of taking 0.0504, you just took 0.05. In that case, your answer will come at around 128. So while doing calculations in the calculator, or you'll be doing in the digital calculator, okay, that is in the system itself. So do not try to cut the decimals very easily. That means just don't terminate here for your ease or to save time, because that might affect the final answer. So wherever decimal is there, at least take to 4 decimal points. So in between your calculations, but any chance you're getting decimals, at least take to 4 decimal places. This will ensure that your final answer is close to the actual answer or the correct answer that will be given in the answer key. So take at least 4 decimal places. Okay. Now let's go to the next question. For a first order reaction A giving 2B plus C, the rate constant in terms of initial pressure P0 and pressure at time T, that is Pt, is given by. So it is given that this is a first order reaction. Okay, so firstly let's try to write the rate constant or equation of rate constant for a simple first order reaction in terms of concentration. So what was that? K for first order reaction is equal to 1 by T ln A0 by A, where these both were concentrations, right? These both were concentrations. And we know that in liquid state, if you say that, or in solution, if you say concentration is represented as concentration itself, but when you go to the gaseous state, we represent concentration in terms of pressure. So let's simply try. In terms of pressure, this is going to be 1 by T ln, instead of A0 we have to write the initial pressure, that is P0, divided by, instead of A is concentration at any time T, that means pressure at any time T is Pt. So 1 by T ln P0 by Pt is going to be your rate constant in terms of pressure. But when you look at the options, there is no options matching for this particular thing. If you can see some Pt minus P0 here, but this is actually not correct because it is different from what we have got. Since there is no direct answer or the one which matches our symbol answer, we have to do some steps. So for that, which is already preferred is to draw the ICE table that you have already learned. So ICE table in the sense A giving B 2B plus C. So initially we know that in any reaction only the reactant is present. So the initial pressure is completely due to the reactant. So P0 is because of A. At that time there were no products, so their concentration is 0. Now at a time T, A is converted to some amount of B and some amount of C. So whatever is gone from this, I'll simply take it as P. Because of some reaction has happened, some amount of pressure of A is decreased. Whatever amount of A is decreased, the double of that is formed in B, right? Because 1 mole of A gives 2 moles of B. If 1 unit pressure is decreased in terms of A, 2 unit pressure of B should increase. Similarly, if 1 unit of pressure of A is decreased, 1 unit of pressure of C should increase because 1 mole of A gives 1 mole of C. This is how you write the ICE table. Here I have not represented the change. I have just given the final concentration in terms of pressure. So this is how it is going to be. This is at time t equal to 0. This is at time t equal to some t. Now what is given is pressure at time t is Pt. That means at time t, when you see in the reaction, you will be having A, B and C, all the three. So the pressure at that time is going to be because of all the three together. That means when I sum these three, I am going to get Pt, right? Or you can write Pt as P0 minus P plus 2P plus P. This both cut. What is left is P0 plus 2P. So one step you can try doing is simply replace Pt with P0 plus 2P. But again there is no options matching because this term P is not there in any option. All the options are based on P0 and Pt, which means you can again do some changes into this. Let's try to find what is P in terms of Pt and P0. So P is going to be Pt minus P0 by 2. Okay, we've got what is P. Now let's write again for Pt. This equation now transforms into K is equal to 1 by T ln P0 by, instead of Pt, I can write P0 plus 2P. But there is a small error here because we cannot write Pt here. Why? Because here A was the concentration of reactant only that is left at time t. But Pt is actually the entire pressure of all the terms together, that is A, B and C, their combined pressure. But in rate constants equation, we will be writing only the pressure of the reactant at time t. So that is going to be P0 minus P and not Pt. That was a mistake on my side. So it is P0 minus P. Now if you write P0 divided by P0 minus P, and the P is going to be this value, that is Pt minus P0 divided by 2. How will this change? 1 by T ln P0 divided by 2P0 minus Pt minus P0 whole divided by 2. Let's take that 2 above. So I will be getting 2P0 minus minus. So this is there is a bracket, so this should go to plus. Okay, I hope you understand that this is going to be 2P0 minus Pt minus minus P0. So this has to be plus P0. So finally you will get 1 by T ln 2P0 divided by 2 plus 1, 3P0 minus Pt. This is going to be the final equation for rate constant. So the mistake that I made here was I took this as Pt initially because I thought that is the pressure for reactant alone. But we see that since the concentration is for reactant alone, we have to write for the pressure of reactant only, and that should be P0 minus P and not Pt. Okay. So final answer is going to be something like this. You will arrive at this by some rearrangement again and again. You will get this. But at every step you have to see whether any matching option is there from the given 4 options. Okay, any option is matching your answer. If not, again you have to do some corrections or rearrangements to that equation. So we see that the correct answer is going to be option B. 2P0 by 3P0 minus Pt. Okay. So I hope that's clear. Let's go to the next question. The potential for a particle in one-dimensional box is given as V of x is equal to 0 for x between 0 and L, and V of x is equal to infinity elsewhere. So we know that for a particle in one-dimensional box, they just defined the box very clearly. So inside the box, that means between 0 and L. If your x is somewhere between 0 and L, the potential is going to be 0. And outside the box, the potential is going to be infinity. Right. The locations of internal nodes of eigenfunction sin of x n greater than or equal to 2 are. So the question is, for a particle in 1D box, whose just the system is explained here, where can we find the internal nodes? Simple question is the position of node in terms of m and n, where n is your state and m is some random integer between 0 and n. So what we know about this is, if you consider psi 1, okay, since n is your state, when you consider psi 1, that means n equal to 1, your node, where is it going to be? There is no node for psi 1, right? So the graph will be like this. There is no node for psi 1, and that is why they have not mentioned psi 1 here. They have started from psi 2 because psi 1 has no nodes. Okay, now in case of psi 2, that means n equal to 2. We know the diagram how that is going to look. For psi 3, again we know the diagram. For psi 4, we know the diagram, and so on. Let's try drawing that. For this, the node is going to be right at the center of the box. What about psi 3? It's going to be 2 nodes on the 1/3 of the box and on the 2/3 of the box. For psi 4, it is like 4 nodes, 1/4, 1/2, 1/4, 1/2 and 3/4. They are the three positions where you will have nodes. So this is what the question is about, but we need to get some kind of equation which will give us the position for this. Now instead of going from this thing and deriving an equation, the easier way is try taking each of these options. Only 4 options are there. Try taking each one of these and put the n and m values. When you put some random n value, you have to take any value for m which is between n and 0 and check which of these will give you the correct answer for all these 4. Not for psi 1 because that is not mentioned in the question. So for psi 2, psi 3, psi 4 and so on, just see which of these options will give the correct value for the position of node. Because we already know the position of node, it's simpler to find it in the reverse way rather than going from the rather than deriving the entire equation. It's easier if you put into the options like trial and error method and try to see if any of the option matches. So firstly, I'm going to start with option A. So they say that the internal node is going to be at some x equal to m plus half by n into L. Okay, they are saying my node will be at m plus half by n into the L. So if I'm considered for psi 2, this has to be valid for psi 2. Psi 2 means, in case of psi 2, n is going to be 2. And since m has to be between 0 and 2, the only option is 1. So m has to be 1. Now if I look at that, I'll put 1 plus half divided by 2 into L. That will be 1 plus half is 3 by 2. 3 by 2 by 2 is 3 by 4 L. So will that be correct? 3 by 4 L. In case of psi 2, are we seeing the node at 3 by 4 L? No. Which means this answer is, this option itself is wrong. So from psi 2 itself we got that this option will not match to give us a node or an equation for the node, equation to find the position of the node. So option A is not an answer. Now let's check for option B. That is simply m by n. So in case of 2, since x is equal to m by n L, for psi 2 I will have x is equal to, since n is 2, m can only be 1, so 1 by 2 L. Does this match? Yeah, 1 by 2 L is actually equivalent to L by 2, and we know that for psi 2 we will get the node at L by 2. So this is actually working in case of psi greater than or equal to 2. Now let's check, it's working for psi n equal to 2. Now let's check for n equal to 3. Okay, so for n equal to 3, this has to be x is equal to, so when n equal to 3, there are two possibilities for m actually. So when n equal to 3, m can be 2, or n equal to 3, m can be 1. Okay, so when in this case your x is going to be m by n of L. M by n means 2 by 3 of L, and in this case it's going to be 1 by 3 of L. So when you look at that, 1 by 3, 2 by 3, both the nodes we are getting from the equation. So that can be a possibility. Let's check for psi 4 also. So for psi 4, n has to be 4, while m can be 3, or m can be 2, and m can be 1 also. Now on using that equation, m by n, it has to be 3 by 4 L, 2 by 4 L, which is equivalent to 1 by 2 L, or 1 by 4 L. You look at that, 1 by 4, 1 by 2, 3 by 4. All the three nodes we have got, which means option B is the correct answer. Don't have to go further because we have tried it for psi 2, psi 3 and psi 4. We have got the correct one. So this is probably the right answer. If m by n into L is satisfying, then m by n plus 1 will not satisfy definitely. And m plus 1 by n plus 1 will also not satisfy. So the correct answer for this question is option B. Next question. The standard Gibbs free energy change for the reaction H2O giving H2 plus half O2 at 2500 Kelvin is 118 kilojoule per mole. The equilibrium constant for the reaction is. So this is a direct question. Let's write down the data first. Given is standard Gibbs free energy. That means delta G0 is given as 118 kilojoule per mole. And the temperature mentioned here is 2500 Kelvin. What we are asked to find is the equilibrium constant, which is K. Now, what is the equation connecting delta G and K? Delta G0 is equal to minus RT ln K. Or if you want to find K, it is going to be e raised to minus delta G0 by RT. Right. That means here I have to do e raised to minus delta G0 is 118 It is kilojoule, so I have to put 3 more zeros, divided by R, 8.314 into temperature, 2500. Here I can do some adjustments. I can cut the 2 zeros. What is left is 1180 by 8.314 into 25. So I'll put these values in calculator. Simply I'll get the answer. The answer I'm getting is around e raised to minus 5.6772. Okay, we need to find now what is this value. So on doing the exponential, negative exponential of this value, we'll get around 3.42 into 10 raised to minus 3. Okay, yeah, so when you look at the options, that is option C. It is directly given. So the K value for this question you got is 3.42 into 10 raised to minus 3. It is a direct question. You just have to remember this equation. And one important thing is here, if you do not put the sign, what happens? Here also you'll miss the sign. Here also you'll miss the sign. E raised to minus 5 point something and e raised to 5 point something, both will give you different answers. So let's try what is the value for e raised to 5.6. So if you try doing e raised to 5.6772, your answer is going to be 292.12. That means if you don't put a negative sign, you will get this answer. Okay, so one thing about this options is that they will be very close enough to make you confusing. When you miss the negative sign and you start doing the problem, you will get the answer, but which is a wrong option. So be careful. You have to study the equations very well with the negative signs and any other thing if that's there. Okay. Next question. At constant volume, 1 kilojoule of heat is transferred to 2 moles of an ideal gas at 180 and 298 Kelvin. The final temperature of the ideal gas is dash Kelvin. So this is, first let's write on the data. At constant volume, that means V is constant. Let's note that down. V is constant. 1 kilojoule of heat is transferred to 2 moles of an ideal gas. So it is mentioned that it is ideal gas, which means somewhere we can use ideal gas equation. Okay. 1 kilojoule of heat is transferred. Q is transferred as 1000 joules. But it is mentioned that it is at constant volume. So what is Q at constant volume? QV. Can we call it as the internal energy U? Okay. Then the data given as number of moles, that is 2. The pressure is given as 1 atm and the temperature, initial temperature is 298 Kelvin. Now we have to find after the transfer of heat, what is the temperature? That is T2. So what is an equation connecting heat and temperature? Or when you supplying heat to a system, how will the temperature change? We have this equation that gives Q is equal to NCV delta T. Or simply CV delta T, that is for 1 mole, and NCV delta T for n number of moles. And we are using VCV because it is at constant volume. So NCV delta T is NCV, it is NCVM into T2 minus T1. Why did we use CVM? Because it is molar heat specific heat capacity into number of moles. Okay, or molar heat capacity into number of moles. That will give you, this is actually CV delta T, or you can write it as NCVM delta T. Now let's put the values. We need to find T2. So Q is given as 1000 joules, N is given as 2, and we need to find CV. Since it's an ideal gas, it is clearly mentioned ideal gas. Ideal gas, we assume they are monoatomic. Ideal gases, they have no interaction with each other, they are monoatomic. For a monoatomic, when we consider translation, rotation and vibration is not possible because only one atom. Only translation is possible. So the degrees of freedom is going to be 3 and the CV is going to be 3 by 2 R. Okay, CV is going to be 3 by 2 R. That is for ideal gas. 3 by 2 into R. Into T2 minus T1. T2 is what we have to find and T1 is 298 Kelvin. Now let's try doing this. 2 will be cut. 3R. 1000 divided by 3R. 1000 divided by 3R plus 298 will give me what is T2. And on calculating, the answer will be around, the answer I'll be getting is 338.09. But the question is to round it off to one decimal place. So this can be rounded off as 338.1 and unit is Kelvin. Okay. This is going to be the final temperature after transferring 1 kilojoule of heat. So the equation that we have learned from here is this one, which is not very common equation that we use, right? So Q is equal to CV delta T or NCVM delta T. Let's go to the next question. Capillary W contains water and capillary M contains mercury. You know what are capillaries, right? Just small thin-sized tubes that we get are called capillaries. So there is capillary W which contains water. Okay, these are capillaries. So just for the illustration, we can actually draw it bigger. So there is capillary W which contains water and capillary M which contains mercury. Water and mercury. The contact angles between the capillary wall and the edge of the meniscus at the air-liquid interface in W and M are theta W and theta M respectively. The contact angles satisfy the conditions. So if you want to answer this question, there is one thing you have to know. That is, in case of water, it will show a concave meniscus like this, because in case of water the adhesive forces towards the sides of the or the walls of the capillary is more than the cohesive force towards itself, so it will just stay towards the wall of the capillary. But in case of mercury, we see a convex meniscus because mercury has more adhesive cohesive force than adhesive force. So cohesive force for mercury towards itself is more than the adhesive force towards the wall of the capillary. Therefore, we see in case of water, we get a meniscus like this. In case of mercury, the meniscus is just the opposite. What is asked is the contact angle between capillary wall and edge of the meniscus. So if you try to draw the contact angle between the wall, that means you're considering this wall and the edge of the meniscus at the air-liquid interface. So the air-liquid interface means it's like this. Okay. In case of mercury, the wall and edge of the meniscus at air-liquid interface, it's like this. Okay. So we have to find is whether theta W and theta M, they are greater than 90 degree or lesser than 90 degree. So one doubt which may arise here is whether we have to consider this angle or this angle, right? So in case for these type of questions, you always have to consider the angle that is inside the liquid. Okay, so angle inside the liquid means this angle is what you have to consider. This is the angle you will be considering. So for water, you will find this is an acute angle. So theta W is less than 90 degree. In case of mercury, the angle inside the liquid is this angle, right? So in case of mercury, theta M should be greater than 90 degree. This angle means you'll be going from here all the way till here. Here, from here all the way till here. This is less than 90 degree, this is greater than 90 degree. So theta W is less than 90 degree. So the options can be C or D, and theta M greater. So the correct answer is option C. Okay. Okay, so next question. Iron is extracted from its ore via the reaction is given below. The volume of carbon monoxide at STP required to produce 1 kilogram of iron is dash liters. So the reaction given is Fe2O3 reacts with carbon monoxide and get reduced into Fe, which is in zero oxidation state, plus 3 carbon dioxide molecules. So this is a method for extraction of pure ion, that is by pure ion by the reduction with carbon monoxide. Now they are asked us how much volume of carbon monoxide is required to produce 1 kilogram of iron. So even though we are asked volume by giving mass, there is one common thing which we can easily find out, that is the number of moles. For 1 kilogram of iron we can find the number of moles, and to find the volume of carbon monoxide, in that case also we can find the number of moles required and then convert into volume. Okay, so always there is a basis, that is the number of moles. So 1 kilogram of iron, how much number of moles is that? It is given mass by molar mass. Given mass is 1 kilogram, that is 1000 grams, divided by 56 is the molar mass of iron. So we need to find the number of moles of iron that is required to be produced. That is, you have to do 1000 divided by 56. 1000 by 56, you will get around 17.85771. Don't terminate your decimals anywhere unless it is 4 decimal points. Now I got the number of moles of iron that is required, but I know 3 moles of carbon monoxide is required to give 2 moles of Fe. 3 moles of CO is required for 2 moles of Fe. So for 1 mole of Fe, how much will I need? 3 by 2 CO is required for 1 mole of Fe. Now the number of moles of iron that I want is 17.8571. So I multiply both sides with 17.8571. So that will be 3 by 2 into 17.8571 moles of CO will give me simply 17.8571 moles of Fe. So these many moles of CO is required. Now one more thing is, CO is a gas. At STP, the volume of 1 mole of any substance is going to be 22.414. We know that, right? For ideal gas at STP it is 22.414, and majority of the gases at the same condition, that is at STP, they will behave somewhat ideally, we can say, but the volume we will be considering is the same, that is 22.4. So at STP, volume of 1 mole of CO is going to be 22.4. So the volume for this much number of CO will be, or this X amount of CO is going to be that value into 22.414, right? So I have to do 3 by 2 into 17.8571 into 22.4. So when I calculate these, I'm going to get, do 3 by 2 into 22.4. I'll get around 600. So this is actually a round value, 600. So your final answer has to be like this, 600 liters. There is no unit conversion needed because volume of 1 mole of any gas is going to be 22.414 liters itself. So the answer will be 600, something around 600. Okay. A galvanic electrochemical cell made of zinc and copper half cells produce 1.1 volt at 25 degrees Celsius. The ratio of concentration of zinc ion to concentration of copper ions is maintained at 1. The delta G0 for the reaction when 1 mole of zinc gets dissolved is dash kilojoule. Now if you see, you can understand this is a question which connects delta G0 to the potential or electrochemical potential, that is E of the cell. So the first equation that should come to your mind is this one, that is delta G0 connected to E minus NF E cell. So delta G0 is equal to minus NF E0 of cell. It is given to us that the E0 of the cell is 1.1 volt and the number of electrons involved it is given 1 mole of zinc, but don't confuse that for N here, because N means the number of electrons involved in the reaction. Okay, it is not the number of moles of ions, it is the number of electrons involved in the reaction. So do not take 1 here. For zinc and copper, since their oxidation state changes from 0 to +2 or +2 to 0, the number of electrons involved is always 2 electrons. And F is a constant, E0 cell is given to you. Well, actually, if you see the question properly, what is given to us can be called as E cell, because what is produced is the E cell. So E cell value is given as 1.1 volt. But it is not different from E0 cell. Why? Because we have given that the ratio of the ions is equal to 1. So the equation connecting E0 and E is E cell is equal to E0 minus 0.0591 by N log concentration of product by concentration of reactant. So product is going to be the zinc ions and the reactant is going to be the copper ions. So when their concentration is maintained as 1, that means their ratio of their concentration is maintained as 1, this part goes to 1, and log 1 is going to be 0, which means this entire term will become 0, and eventually you will get E cell is equal to E0 cell. So instead of E cell that is given, you can replace it with E0 cell and use. So delta G, you have to find delta G0, that is equal to minus NF E cell. Minus 2 into Faraday, we know the value when it is given. We know the value is 96500, but don't use that here. Why? Because they have given a value, it is 96485. Okay, when a value of any constant is given in the question, even though you might have studied some different value, you have to be using the given value. They are almost equal, but your answer should be closer to the actual value, right? For that reason, you have to take whatever is given in the question. So F, do not, we have a tendency to quickly take it as 96500, but since it is given in the question, we have to take that value only. 96485 into E0, we have found it to be 1.1. If we calculate this, we will get it around 212. It is going to be minus 212. Do not forget the minus sign. 267. This much, what is the unit for this case? It's going to be joules. But look at what is asked. What is asked to us is in terms of kilojoules. So you have to write in terms of kilojoules. So let me try writing in terms of kilojoule. It is 10 raised to minus 3. So there should be a point here. Minus 212.267 kilojoules. Now can I write it as it is? No, because they have asked to round off to the nearest integer, which means you should not be putting any decimal values, and if you put decimal values, you will lose your marks even if it is correct. Which means if you go write this value as it is, you will not be getting any marks. Okay, you have to be writing round it off to the nearest integer. Since it is 2 here, this will remain as it is, and the final answer is going to be minus 212. So you have to be very careful with this question or questions like this, because there are many tricky part here. First is the Faraday's constant is not what we usually take. It is given as 96485, which is slightly different. So if you do not look at that and carelessly take 96500, you will not get the correct answer. Okay, first thing that. Second thing is, we'll get the answer in joules. We need to convert it into kilojoules. Okay, not just converting, we have to round off the decimal place such that you'll be getting only an integer. There should be no any decimal values. You should definitely get or write in terms of integers. So these parts should be very careful about these parts while writing exam. Just because you know the theory or the equations very well, there is no guarantee that you will get marks, right? For your answer to be correct, you have to be very careful about these slight things which comes in the exam. So these are the questions we had to discuss. Okay. And one question which we left here was that for determinants, you have to find the determinant of a 3 by 3 matrix, which you can do it by yourself actually. So max questions are very rarely asked for JAM, but just in case it is asked, you can answer it, right? So this is actually a very common topic you might have studied from your grade 12th or even in your BSc level. So just find out how to do this. The answer is already given here. Answer is option A. Make sure you arrive at this answer, and the rest we have done it. Okay, so thank you.